Good day everyone! In this video, we will create a simple combinational circuit using the inverter, OR, and AND gates. The combinational circuit of different logic gates are usually evident in modern computers or microprocessors, which are often present to work alongside with each other and perform or create more complex logical conditions. This type of circuit design are often utilized, especially by the electronics engineers. Our objectives in this activity are: Number 1, to familiarize ourselves with the breadboard and the principal logic circuits. And number 2, to demonstrate and simulate the basic function of the 3 integrated circuits or ICs. Before we begin, let's review some basic safety precautions when handling electronics. Number 1, use personal protective equipment when necessary. That is, to use rubber gloves and safety goggles. Number 2, to avoid wearing static-prone clothing and ground yourself properly to prevent harm or damage to components. 3, handle all components correctly and with care, especially the sharp pins of the electronic parts. And number 4, unplug the power supply when not in use. As for me, I'm not wearing a PP right now because we are only handling a 5-volt battery supply, which is not dangerous when handling with our bare hands. Now, let's prepare the following electronic components and materials before we start. We need one 5-volt battery. In our case, we use a Raspberry Pi hooked to a power bank. We also need one large breadboard, some solid wires or jumper wires, 4 5mm LEDs, 7 2 kilo ohm 1/4 watt resistors. Alternatively, in our case, we only have 100 ohm 1/4 watt resistors. We also need one 74LS04 IC, or the NOT gate. We also need one 74LS08 IC, or the AND gate. And lastly, we need one 74LS32 IC, or the OR gate. We also need 3 4-pin buttons, pliers, scissors, and optional are multimeter and tweezers. Since I don't have a multimeter on hand, I'll just simulate my circuit. Let us begin. Step 1. While optional, I encourage you to prepare a circuit diagram to quickly and efficiently have the installation of components on the breadboard. Number 2. Prepare your breadboard and decide where to connect the positive and ground lines. Number 3. Place the 74LS04 IC, 74LS08 IC, 74LS32 IC, and the 4-pin buttons carefully according to the circuit diagram. Handle the components with the sharp sides away from you to avoid injury. Step 4.
Pair each of your 4 LEDs with a 2 kilo ohm 1/4 watt resistor and place them on the breadboard according to the circuit diagram. It is recommended to cut the wires of these components to snugly fit them on the breadboard.
Step number 5. Once all the essential electronic components are in place, use the solid connecting wires to connect them, following the circuit diagram. Use pliers or strong scissors to strip the wires and cut them according to the given configurations. Arrange them neatly and minimize the overlapping of wires. It is recommended to have a box or a place for your wire cuttings to avoid harm. Step number 6. It is essential to ground your buttons for them to function properly. This is to clearly define the logic levels such as 1 or 0 inputs by having a main ground reference. Step 7. Connect the positive and negative sides of the battery to the appropriate lines of the breadboard. Step number 8. Review all circuit components if you encounter any errors in the assembly. Now that the circuit is assembled, what do we observe? As shown in the given truth table for the circuit, we have created a 3-input system, resulting in 8 possible outputs. Following the formula 2 to the power of n, where n is the number of inputs or buttons. By using the combination of the integrated circuits, 74LS04 or NOT gate, 74LS08 or the AND gate, and the 74LS32 or the OR gate, we have formed a composite logic circuit that produces different output patterns and LED configurations. Upon further analysis of the truth table and circuit diagram, we can deduce that each LED corresponds to a specific logic equation that determines whether it lights up or not. LED 1 is given by AB prime plus A prime C, LED 2 as AC plus A prime C, LED 3 as B plus C prime, and LED 4 as A prime plus C prime. This circuit demonstrates the foundational principles behind modern digital systems. Most devices today, including computers and smartphones, rely on the combination of thousands of logic gates operating at extremely high speeds to perform complex tasks, such as processing this video data or managing multiple applications simultaneously. Additionally, gate-level minimization plays a critical role in circuit design. This process simplifies the circuit into fewer logic gates while maintaining the same functionality, which is crucial for reducing the number of components, saving power, and improving efficiency. For example, in real-world applications, these logic gate combinations are used in the design of microprocessors, memory devices, and control systems. That would be all for this video. Thank you for listening.